across scenarios where you may have some server, let's say, which everyone should access. Let's say there is my FTP server, and I want to ensure that all my users of VLAN 10, which is accounts department, and also marketing department, should be able to access my FTP server, which is in different VLAN. To reduce the size of the broadcast domain, we divide them in different VLANs, and also it will ensure that we don't have communication between different VLANs. But you may also require to have communication between the VLANs, maybe some restricted communication. In that case, what we can do is we can do something called Inter-VLAN routing. Now, using Inter-VLAN routing, we can allow the users of one VLAN to communicate with another VLAN. So, but for this, you need to have a layer 3 device. So, in order to make this possible, you need to have a layer 3 device. Now, using this layer 3 device, what I can do is I can ensure that all the users, let's say there is a FTP server, I can ensure that these users can access FTP server through router, and on the router I can apply some filtering, like I can apply something called ACLs, and based on that filtering I can also allow or deny a specific traffic. Let's say I have I want to ensure that for users on the VLAN 10, everyone can access this FTP service, but the users on the VLAN 20 should not access this FTP service. So in order to do that, it has to go via router because they are in different VLANs. Now on the router I can define an ACL, some layer 3 security, which can allow you to filter the packets. So in this way we can also ensure that we have a communication between the VLANs. At the same time, we can restrict the communication between them by using some layer 3 filtering concepts like ACLs. Okay. So there are multiple ways of doing this. VLANs essentially are isolated from each other. They will not communicate with each other, so that the packets from one VLAN will never go to another VLAN. In order to ensure that if you want to send the packets from one VLAN to another VLAN, we need to have a layer 3 device. So which means we need a router. So there are multiple ways of doing these things, like if you want to do inter-VLAN routing, there are 3 different methods. The first one is the old legacy method, the one of the first methods which was introduced by using a separate physical interfaces for each VLAN, and then after that there is a disadvantage that if you have VLAN 1 user and VLAN 2 user and VLAN 3 user, if they want to communicate, you need to have 3 separate physical interfaces for each and every VLAN. So which means if you have 10 VLANs, you need to have 10 physical interfaces, and each and every interface will act as a gateway for every VLAN. Now there is a drawback with this one. That's the reason then later on we have a concept of router on stick, where we can use a single router with one interface, and we can configure this interface as a trunk link, and then we can use sub interfaces by using one physical interface, but still the traffic will be differentiated in each and every sub interface. That is one method. And then finally we are using, now most commonly used is using the L3 switch, where we are going to create one SVI interface, a logical interface. So we'll see much more in detail about this. Let's get started with the first method. We'll see, anyway it's an old legacy method, no more used, but still we'll see some of the basic lab which is going to explain how we can do that. So this is my first method of using doing the inter-VLAN routing, where I have a VLAN 10 users want to communicate with VLAN 20 users. So if you have VLAN 30, then it's okay. So we can also have VLAN 30, VLAN 40, any number of VLANs. So just for simplification, I'm using only 2 VLANs, and I want to ensure that my traffic between the VLANs should go through my router. So router is a device. But now the question is, we just have only one router, right? So we just need one single device, that is router, but you need to have at least 2 physical interfaces for each VLAN, where one of the physical interface will act as a gateway for VLAN 10, and the other interface will act as a gateway for VLAN 20. So if you have 3 VLANs, you need to have 3 separate physical interfaces. And then if you have 10 VLANs, 10 separate physical interfaces. And then the opposite side of the interface. So this one, the opposite side of the interface must be, let's say this is a port F0 by 10, this is F0 by 11. Now this port must belong to VLAN 10, because now this is a gateway, right? Gateway of VLAN 10, which means the opposite facing interface has to be a part of the VLAN 10, and then the interface which is acting as a gateway, this is a gateway for VLAN 20, and the opposite facing interface has to be in the VLAN 20, just like we configure these two ports in VLAN 10, these two ports in VLAN 20, similar way. But overall you need to have three interfaces in VLAN 10. The one is connecting to router, and then the other two interfaces which belongs to my VLAN 10 host. So it can be more than two. A similar way, the gateway opposite facing interface has to be in the VLAN 20, and then these two interfaces has to be in the VLAN 20. So now you will have two separate broadcast domains. Now this broadcast domain will have three ports, and then the other broadcast domain, the blue ones, will have three different ports. So there are two different broadcast domains. So the traffic coming from VLAN 10 will be broadcasted or sent to this port, and from there it reaches the router. Router is going to check the routing table, and it will realize that the 2 dot network is on F0/1, and it will send back on this port and reaches the VLAN 20, and then finally reaches the VLAN 20 host. That's how the communication happens. So let's try to verify this practically. So I got a same exact diagram in my packet tracer program, so I'll be using that here. I got the routers, two routers, and one router with two links, and I got hosts which are connecting 192.168.1.1. I'm going to use the same IP addressing what I have here. So this will be my 192.168.1.1 host, 192.168.1.2 host, and then this is my addressing. So except the IP addressing on the PCs, everything is nothing is pre-configured. Only this part is pre-configured. So if you want, you can go to PC, verify. On the first host, you can see the IP addressing. I'm using 192.168.1.1 with a default gateway of 192.168.1.100. Why? Because I'm going to use this as a gateway, and the IP address I decided to be 192.168.1.100, which has to be in the same network what I'm using in my VLAN. Now similar way, if I go and check on the second device, let's go to the second device. If you try to verify, the IP addressing is exactly the same what is shown in the diagram. In the same way, third device, now I can move to the third device and fourth devices. So IP addressing is the only part I pre-configured here. And then on the PC4, this one, 192.168.2.100. So now in my scenario, I have these two users. Part of this is a gateway, and for these two users, gateway is 192.168.2.100. And on the switch side, I do not have any configuration. So I'll go to switch, and then I will try to assign these three ports. What are the three ports we need to assign? In my scenario, if I check show IP interface brief, so I think I'm using F0/0, F0/10 port, and F0/11 port. So it's not 10, it has to be F0/11. So what I'll do is I'll try to assign three ports. What are those three ports we need to assign? So I'm going to assign F0/10 and F0/1, F0/2 in the same VLAN, these three ports. So let's try to configure. So go to switch. If I go show VLAN, I don't have any VLANs created. So first step, I'll create the VLANs, and I'll give some name. Done. And then I'm going to shift the port F0/1-2, which means 1 to 2, because my two devices are connecting on port number 1, port number 2, and the interface which is connecting to my router to opposite side, which is a gateway, that is F0/0, is F0/10 port. So I'm going to shift these three ports in the same VLAN. Switch port access VLAN, VLAN 10, switch port mode access. Done. Now similar way, I'm going to shift F0/3 to 4, which means the interface is 3 and 4, and then the interface which is facing towards the router 1, F0/1 interface, so which is my gateway for VLAN 20, it is F0/11. So I'm going to say switch port mode access, switch port access VLAN 20. Now similar way, if you have more number of VLANs, the same way you need to do. So that is something we need to do in our switches. Just we have to shift the ports into the respective VLANs. The next thing, moving on to the router configuration. Now on the routers, what we need to do, we just need to assign the IP addresses to the interfaces the same way what we do in our normal routing configurations. There is no extra configurations. I just go to my interface F0 by 0 interface. I'm going to give no shutdown, and I'm going to say IP address F0 by 0 is 192.168.1.100, and then 255.255.255.0. And interface F0 by 1 will be my gateway for the secondary VLAN, which is my second VLAN, that is VLAN 20, and I'm using 192.168.2.100 as my gateway address. No shutdown. So if I verify the interface IP addresses, F0 by 0 is 1.100, F0 by 1 is this, and now from here I can be able to ping to each and every host, because the router must be able to ping each and every host in the LAN from VLAN 10 or VLAN 20. It doesn't make difference, because the router belongs to both the VLANs, because the router is having both the interfaces in the respective VLANs. So there is some problem here. So the problem is I might have assigned wrong interfaces. So I'm not sure which interface I have assigned. So which means it's not able to communicate, means I think I'm not using F0 by 11 port. Okay, so it's F0 by 11 only. So let's check show IP interface brief. So let me try to ping one more time this time. Yep. So it was just taking a time for the interface to come up. So you can see it's pinging. So this will ensure that you have a communication between your router, that is a gateway, and your LAN interfaces. Now next thing, what I should do is I need to verify that these users on the VLAN 10 must be able to ping to VLAN 20 in the same way what I discussed. So I'll go to any one of the physical computer. So I'll be on 192.168.1.1 if you verify the IP address, and I'm trying to ping to 1.2. 1.2 is on the same network, so same VLAN as well, so definitely it will communicate. Now if you try to ping to 2.1 or 2.2, which is a different network and different VLAN, still you can communicate. If you try to trace for verification, trace cert command to trace the packet how it's traveling. So it's first it goes to 192.168.1.100, that is my router, and from the router again it is sent back on the F0 by 1 interface, because the router knows about both the networks. So you don't need to do anything. So on the router, just we need to assign the IP addresses, and when you use show IP route, you should see those two connected interfaces. Now ensure that the routing is enabled, because if you have this command, if you just have routing disabled, in that case you will not see these kind of interfaces. So only the thing you need to ensure that routing is enabled, but by default in all the routers IOS, routing is something by default enabled. Okay, so this is the way we can have inter-VLAN routing communication with a old legacy method by using a separate physical interfaces for each and every VLAN. So the major disadvantage with this one is we need to have let's say if we have 10 VLANs, we need to have 10 separate physical interfaces, which means it is not scalable for big size networks, and also more number of interfaces means it's going to be a little bit expensive for the administrator again to add multiple physical interfaces for each and every VLAN.